Hi there. In this interview, we are going to simulate a real conversation about SLOs, SLAs, and error budgets. These are concepts that sound simple on the surface, but often expose whether someone truly understands reliability at scale. I want you to treat this like a live interview. When I ask a question, pause the video and answer it out loud before you listen to the sample response. Compare your thinking to what a strong candidate might say. If you want more deep dive DevOps simulations like this, subscribe and follow along with the series. Warm-up behavioral questions. First question. Tell me about a time when a service you owned was meeting its SLA, but users were still unhappy. What did you learn? A strong candidate might say something like this. In one of my previous roles, we had an external SLA of 99.5% uptime, and we were technically meeting it. But we started seeing user complaints about slow checkout flows. When we dug in, we realized our uptime metric was binary. Either the service was up or it was down. But latency was spiking during peak hours. From a contractual perspective, we were compliant. From a user perspective, the experience was poor. That pushed us to define proper SLOs around latency percentiles, not just availability. We introduced a 95th percentile latency SLO and tied alerts to it. The big lesson for me was that SLAs protect the company legally, but SLOs protect the user experience. If you only optimize for the SLA, you can miss what actually matters. Next question. Have you ever had to push back on leadership about reliability targets? A strong candidate might respond like this. Yes. In one situation, leadership wanted a 5 nines availability target for a new internal platform. I understood the intention, which was to signal high reliability, but I also knew the cost and complexity required to get close to that level. I gathered historical incident data, current architecture limitations, and industry benchmarks. Then I explained what 5 nines actually means in downtime minutes per year, and what architectural changes would be required. Instead of saying no, I reframed the conversation around trade-offs. We eventually agreed on a lower SLO that aligned with business impact and staged improvements over time. The key was grounding the discussion in measurable outcomes and cost rather than emotion. Third question. How do you handle teams that repeatedly burn through their error budget? A strong candidate might say something like this. If a team consistently burns the error budget, I treat it as a signal rather than a failure. I look at patterns. Are they shipping too fast without guardrails? Are there systemic issues like flaky infrastructure or weak test coverage? In one case, we implemented a policy where if the error budget was exhausted, feature releases paused and focus shifted to reliability work. But we also supported the team with tooling improvements like better canary analysis and automated rollback. I try to avoid making it punitive. The goal of the error budget is to create balance between velocity and reliability, not to shame teams. Transparency and shared ownership usually works better than strict enforcement. Core technical and scenario questions. Now let us move into the technical side. First question. Explain the difference between SLA, SLO, and error budget in practical terms. A strong candidate might answer like this. An SLA is an external commitment, usually contractual. It defines the level of service we promise to customers and often includes penalties if we fail to meet it. An SLO is an internal target that defines what reliability we aim to achieve. It is usually stricter or more granular than the SLA and is based on measurable indicators like latency or availability. The error budget is derived from the SLO. If we set a 99.9% availability SLO, that means 0.1% of requests can fail within a given period. That 0.1% is the error budget. It quantifies how much failure we are willing to tolerate while still meeting our objective. I think of the SLA as the contract, the SLO as the goal, and the error budget as the allowable risk. Next question. Suppose your API has a 99.9% availability SLO measured monthly. Mid-month, you have already consumed 80% of your error budget. What do you do? A strong candidate might think through it like this. First, I would confirm that the measurement is correct and that the incidents were real user-impacting events. Assuming they were, consuming 80% of the budget halfway through the month is a warning sign. I would assess the root causes. Were they one-off outages or recurring patterns? Then I would communicate clearly to stakeholders that we are at risk of breaching the SLO. Practically, I would consider slowing down high-risk changes, increasing monitoring sensitivity, and prioritizing reliability fixes. I would not automatically freeze all deployments unless the risk is extremely high, but I would make risk-conscious decisions. The error budget is meant to guide behavior. If it is nearly exhausted, we shift towards stability. Third question: how do you choose a good SLO for a new service that has no historical data? A strong candidate might respond like this. For a new service, I start by understanding user expectations and business criticality. Is this service user-facing or internal? Does downtime block revenue? Then I look at comparable services in the industry for baseline expectations. Without historical data, I might start with a conservative but realistic SLO, such as 99.5 or 99.9%. Depending on the context. I also ensure that we have proper instrumentation before locking in the objective. An SLO is meaningless if you cannot measure it accurately. I treat the first few months as calibration. We collect data, review performance, and adjust the SLO once we understand actual behavior and system constraints. Next question: what metrics would you use to define SLOs for a web application? A strong candidate might think aloud like this. For a typical web application, I would define SLOs around availability and latency at minimum. Availability could be defined as the percentage of successful HTTP responses over total valid requests, excluding client-side errors. For latency, I would focus on percentile-based measurements, like the 95th or 99th percentile, because averages hide tail latency issues. Depending on the application, I might also define SLOs around error rate for specific critical endpoints, like checkout or login. The key is tying the SLO to user experience. If users perceive slowness above 2 seconds as unacceptable, then that should shape the latency objective. SLOs should reflect user visible outcomes, not just infrastructure health. Final question for this segment. Why is chasing higher and higher availability sometimes the wrong goal? A strong candidate might answer like this. Pursuing extremely high availability has diminishing returns. Each additional 9 requires disproportionately more complexity, redundancy, and operational overhead. That means higher cost and potentially slower development velocity. If the business impact of downtime is relatively low, investing heavily to achieve ultra-high availability may not make sense. Also, complexity itself can introduce new failure modes. I believe reliability targets should align with business value and user impact. Instead of blindly chasing more 9s, I prefer to ask what level of reliability is sufficient for the product and then design within that boundary. Next question. Here is a scenario. Your company has a public SLA of 99.9% availability, but internally, your SLO is also set to 99.9%. Is that a problem? A strong candidate might think through it like this. Yes, that is usually a problem. If your internal SLO is identical to your external SLA, you have no safety margin. That means any internal breach of your SLO directly risks violating the SLA and potentially triggering penalties. In practice, I prefer to set internal SLOs stricter than the SLA. For example, if the SLA is 99.9%, maybe the internal SLO is 99.95%. That gives you a buffer for unexpected incidents. I also consider measurement differences. Sometimes the SLA might be calculated differently, such as monthly uptime percentage measured at the edge, while the SLO might be based on request-level success rate from a specific region. If the measurement systems differ, the alignment becomes even more important. Without a buffer, you are essentially operating at the edge of your legal commitment all the time, which is risky both operationally and financially. Next question. Imagine you define an SLO based on availability, but you start seeing subtle data corruption issues that do not cause downtime. Users can still access the service, but some responses are incorrect. How do you handle that? A strong candidate might respond like this. That scenario highlights a common limitation of simple availability-based SLOs. If the service returns HTTP 200 responses, but the data is wrong, technically availability metrics might look fine. So the first thing I would do is acknowledge that our current SLI does not capture correctness. I would evaluate whether we need additional SLIs. For example, we might define a correctness SLI based on validation checks, error rate of downstream reconciliation jobs, or comparison against a trusted source. The challenge is measuring correctness reliably without adding too much overhead. There is also a trade-off here. The more dimensions you add to SLOs, the more complex the monitoring becomes. But if the business impact of incorrect data is high, such as financial transactions, then it is worth it. So I would propose expanding our SLO framework to include signals that reflect data integrity, not just uptime. Let me give you another scenario. Your product team wants to launch a high-profile feature before a major marketing event. However, your service has already consumed 90% of its error budget for the current window. Leadership is pushing for the release anyway. What do? A strong candidate might think through this carefully. First, I would make the current reliability state visible. I would clearly show how much of the error budget is left and what that implies. Then I would assess the risk profile of the new feature. Is it isolated behind a feature flag? Can it be rolled out gradually? Does it affect critical paths? If the feature can be deployed safely with mechanisms like canary releases, automated rollback, and traffic shaping, I might propose a limited rollout with tight monitoring. If it is high risk and touches core systems, I would recommend postponing until the next window. The key is not to blindly block progress, but to use the error budget as a decision-making tool. It is not about saying no. It is about making the risk explicit. If leadership still chooses to proceed after understanding the trade-offs, that becomes a documented business decision rather than an operational surprise. Next question. How would you implement SLO monitoring in a real production environment from scratch? A strong candidate might explain it step by step like this. I would start by defining clear SLIs that reflect user-visible outcomes. For a web API, that might be successful request ratio and latency percentiles. Then I would instrument the service to emit the necessary metrics, ideally at the edge or gateway level to capture real traffic. Next, I would ensure that the data collection system can aggregate over defined windows, such as rolling 30 days or calendar months. It is important to align the calculation window with business reporting expectations. Then I would implement alerting based on burn rate rather than just threshold breaches. Burn rate alerts tell you how quickly you are consuming your error budget. For example, if the service is failing at a rate that would exhaust the monthly budget in 2 days, that should trigger a high urgency alert. I would also build dashboards that show current SLO compliance, error budget remaining, and historical trends. Finally, I would socialize the SLOs with development teams. If they do not understand or buy into the SLO, it becomes just another metric on a dashboard with no behavioral impact. Let me ask something more nuanced. What are the risks of choosing an SLO that is too strict? A strong candidate might answer like this. If the SLO is unrealistically strict, teams may constantly operate in violation. That can create alert fatigue and erode trust in the reliability framework. It can also slow down innovation because teams are always in reliability recovery mode. Another risk is misallocation of resources. If you set a 99.99% SLO for a non-critical internal tool, you might spend engineering effort on redundancy and failover that delivers little business value. There is also a psychological component. If the SLO is perceived as unattainable, teams may disengage. So I prefer to set SLOs that are ambitious but grounded in historical performance and user needs. They should drive improvement without creating permanent crisis mode. Final question in this section. How would you handle different SLOs for different customer tiers? A strong candidate might reason through it like this. If the business model includes premium customers with stricter expectations, it can make sense to define differentiated SLOs. However, this increases architectural complexity. You may need traffic segregation, prioritized routing, or dedicated capacity. I would first evaluate whether we can logically isolate traffic by tenant or plan. If so, we can measure SLIs per segment and enforce different objectives. If not, promising different SLOs might be risky because shared infrastructure failures could impact everyone. There is also a communication aspect. Sales and customer success need to understand what is realistically achievable. From a systems perspective, differentiated SLOs often push you toward stronger isolation boundaries, such as separate clusters or resource pools. That has cost implications. So I would approach it carefully, ensuring that the technical architecture supports the business promises, and that monitoring is granular enough to validate compliance per customer segment. Pressure and judgment questions. Let us move into more difficult territory. Here is the first scenario. Your company has never formally defined SLOs. Leadership suddenly wants them implemented within 1 quarter because an enterprise customer is asking for them. You know the data quality is inconsistent and monitoring coverage is incomplete. Do you rush to define SLOs anyway, or do you push back? A strong candidate might respond like this. I would not rush to define superficial SLOs just to satisfy a checkbox. If we publish unreliable or poorly measured objectives, we risk losing credibility both internally and externally. However, I also would not simply push back without offering a path forward. I would propose a phased approach. In the short term, we can define provisional SLOs based on the best available signals, clearly labeling them as baseline or pilot metrics. At the same time, I would outline a plan to improve instrumentation, fill monitoring gaps, and validate data accuracy. I would communicate openly with leadership about the risks. If SLOs are tied to contractual commitments, we need confidence in how they are calculated, so my decision-making would balance urgency with integrity. It is better to launch slightly later with solid foundations than to commit to numbers we cannot defend. Here is another scenario. You have an SLO breach that technically violates your target, but user complaints are minimal and business metrics look strong. Do you treat it as a serious incident? A thoughtful candidate might say something like this. I would first validate the breach. Was it a genuine degradation of user experience, or was it an artifact of measurement? If it is real, even without visible complaints, it signals risk. Sometimes users tolerate degradation temporarily, but churn later. However, I would scale the response proportionally. Not every SLO breach requires a war room. I would assess severity, duration, and impact. Then I would decide whether it warrants a formal incident review or simply a corrective action ticket. The key is to avoid overreacting or underreacting. SLOs are guardrails. They help us detect trends before they become crises. So even if the business impact appears small today, I would analyze root causes and prevent recurrence, but without creating unnecessary panic. Let me make this harder. Your service consistently meets its SLO, but the engineering team is burned out because they are constantly firefighting near misses. They are operating right at the edge of the error budget. What do? A mature answer might sound like this. Meeting the SLO is not the only goal. Sustainable reliability matters. If the team is constantly stressed, that is a warning sign. It suggests the SLO may be achievable but fragile. I would look at leading indicators such as burn rate spikes, deployment instability, or lack of automation. Then I would advocate for investment in resilience work, even if we are technically within targets. There is also a cultural element. If the team feels pressured to operate at maximum capacity just to stay compliant, that is unhealthy. I would facilitate a discussion about whether the SLO is realistic, whether capacity buffers are sufficient, and whether we need to rebalance feature work versus reliability work. Reliability should reduce stress over time, not institutionalize it. Another scenario. A large customer demands a stricter SLA than your current architecture can realistically support. Sales is excited about the deal. Engineering knows it will require significant redesign. Do you accept the contract? A strong candidate would approach it carefully. I would quantify what meeting that SLA actually entails. Does it require multi-region active-active deployment, higher redundancy, stricter failover times? What is the cost impact? Then I would align with both sales and leadership. If the deal revenue justifies the engineering investment and infrastructure cost, it may be worth it. But if the margin is thin and the reliability requirements are extreme, we may be setting ourselves up for long-term strain. The worst outcome is promising reliability we cannot deliver. That damages trust. So my decision would be data-driven. I would present trade-offs clearly and let the business decide with full visibility into the operational implications. We have covered definitions, trade-offs, implementation details, and now judgment under pressure. SLOs, SLAs, and error budgets are not just technical constructs. They are tools for aligning engineering work with business priorities. They influence when you ship, when you pause, and when you invest in resilience. I want you to reflect on this. Which question in this interview made you hesitate the most? Was it the scenario about launching a feature with little error budget left? Was it the decision to accept a stricter SLA? Or was it the tension between meeting targets and preventing burnout? Pause for a moment and think about how you would answer in a real interview setting, without preparation, under time pressure. The goal is not memorization. It is clarity of reasoning. Interviewers are listening for how you weigh risk, how you communicate uncertainty, and how you connect technical decisions to business impact. If you found this format useful, subscribe so you do not miss the next simulation. Each session is designed to push your thinking a little deeper and prepare you for real-world conversations. And as always, before you move on, replay the toughest question and answer it out loud. That is where the real learning happens.